get a chance to watch it later. Okay, so basically, I'm not sure if you guys, were you guys able to print the set of notes off?
Oh, are we supposed to print them on?
Yeah, I didn't.
I didn't know.
Okay, so no worries. So maybe then today we'll just go through, you can do a couple of the examples as we go. So don't worry about writing all this, because if you print off, this is outcome 9C that we're doing, okay?
Okay.
So for Thursday, maybe print off a set of notes, because in that, you guys, that's where your assignment package is, right? You know how I usually gave you the notes package? It always had your assignments in it as well. So you'll probably want to print that off if you can. Okay, so today what we're going to look at are exponential functions. Kind of fitting considering why we're sitting at home right now and why we are in kind of lockdown mode. You think of the COVID virus, and if you've been on the internet at all and looked at any graphs, any of the graphs are a pure exponential graph. So if we want to talk about looking at, hey, we never learned something that's connected to real life. This is totally 100% connected to real life. So any graph, like I've looked at a million different types of graphs between world, numbers of COVID-19 and even looking within our own province or within Canada, and they all have this trending look to them, a general idea of it's looking like an increase as it goes and it's trying to spike. Ideally, we are going to, they keep saying, oh, we want to flatten the curve, right? So it's saying, ideally, we don't want this to continue up in this direction. We want to make sure that it comes and it starts to flatten, right? We want this to not keep spiking. We're trying to find a way to kind of reduce that down. So that's when they start to talk about flattening that curve. It's about not allowing this to continue on, but allow it to kind of flatten this way and hopefully can start to decline, right? That's our hope with what's happening in the world right now. But as it stands right now, any graph you look at is spiking like this. We're trying to find out where is it going to peak. So when you hear of the country saying, hey, where's it going to peak? This is what we're looking at. It's still going up in this direction. It's not actually starting to flatten. So an exponential function is usually denoted as this y is equal to c to the power of x, okay? So where this c is just your base value, okay? It can be any number in there, but that number in here will determine whether or not we have a graph that looks like this, which in this case is what we consider an increasing graph. So if it's, as you read it from left to right, it's going up, that's considered an increasing graph, or what we call, it's got a growth, okay? Like it's exponentially growing as we go in this direction. The other graph that we see is, hey, if it's, as we read it from left to right, it's decreasing as we go. So in this case, this would be considered a decreasing graph, or you might have heard of exponential decay. So as certain isotopes, or you may have heard that in science when you're talking about decay, like exponential decay. So decreasing and decay go hand in hand, where growth and increasing go hand in hand. Now, that C, that base, if it is larger than 1, so if your C, your base is larger than 1, you are dealing with an increasing graph. So that's where C is greater than 1. So it will have a base of 2 to the power of x. It could have any value that's larger than 1, okay? If your function has it where it is, if your C is between 0 and 1, so it's basically creating that decimal in there, then you're going to be working with a decreasing graph. So in this instance, you could have a graph where it's like 1/2 to the power of x, okay? So as long as C, that value, that base, is between 0 and 1, you're dealing with a decreasing, okay? If C is larger than 1, so it might be y to the equal to 2 to the power of x, okay? Now, granted, that's not what these actual graphs are, but I'm just giving you an example of what that C would look like if we were working in that situation. Questions on that?
Nothing.
Nothing at this point.
So it's just if it's like a decimal or something like that, it's decreasing, and anything above 1 is increasing?
Right.
Okay.
Right. Essentially. Like this, I could have put this as a decimal as 2.1, and it would still be considered increasing, right? Yeah. Okay.
Yeah.
So let's have a look at this then. So there's lots of things that we can pull from it. So when we look at a graph, we can identify what the domain is, what the range is, any intercepts. So if we're looking at X and Y intercepts, or any asymptotes. Remember an asymptote like we did, when would you have done asymptotes? You would have done a little bit in pre-calc 20, I guess, right? Where an asymptote is where you're coming right close to the edge, you know, of something, but you never cross. So in this instance here, this right here, y is equal to 0, like your x-axis here, is actually considered an asymptote in this case because this graph is following really closely along, but it never actually intersects or never actually crosses that x-axis. Same thing in this direction too, right? This is coming really, really close to your x-axis, but it never actually touches it. So this would be considered an asymptote, okay? And that asymptote, because it's crossing at y is equal to 0, it is y equals 0 as an asymptote there. And we'll talk a little bit more about asymptotes as we move through this, but for the time being, that's kind of where we're at with that. We're also going to talk about transformations, okay? Not today, not in, and I'm trying to think if we even actually get to transformations in this section. I don't think in 9C, oh yeah, we do get to some transformations. Okay, so we will touch base on that probably after Easter break. We'll worry about that. So, or maybe even on Thursday. We'll see, who knows? Okay, so let's take a look at a graph. So let's say we have this lovely exponential function, y is equal to 6 to the power of x, okay? Well, in order to do these, your best bet doing these is to work through and use a table of values, okay? So in this instance, when we do a table of values for these, let's pick some kind of standard values. And in this instance, I think you're going to pick values for x, okay? Because your x is in here, and then once we've solved this, we can figure out what y is going to equal. So your usual thing, probably pick a couple negative, pick 0, pick 1, and pick 2. So pick some positive, put some negatives in, kind of our usual what we've been doing all the way along, right? So the fun part of it is, so let's start at the positive ones at the bottom, because they're easier to kind of work with as we plug in. So if I take and put a 2 in for x, 6 to the power of 2 is going to give me 36. Okay, I put a 1 in. Well, 6 to the power of 1 is still going to give me 6. This really tests our exponential understanding again, all the powers and exponents rules. Okay, I put 0 in for x now. 6 to the power of 0, what does that give us?
0.
Oh, what's anything to the power of 0?
1.
Wait.
Yeah,
Yeah.
right? Anything to the power of 1, which, take a look up here. So if we put 0 in for x, you're noticing without any transformations happening, we are always going to cross through at that on the y-axis at 1, which holds true to what we've got going on here, right? We're going to end up crossing that y-axis at 1. Okay, now the fun begins. Now I'm going to put a negative exponent in for x. So I put a negative exponent in for x. That, remember, so this is really saying I've got 6 to the power of negative 1. Well, put that over a 1, right? Because we can't really calculate this as a power of a negative exponent. So I'm going to need to actually make this exponent positive. And in order to make this exponent positive, that means I'm going to move the base and that negative exponent. I'm going to shift it down, take the reciprocal of it. So I really have this as 1 over 6 to the power of a positive 1. Okay? So really, what I have in here, when I put a negative 1 in for x, I really have this as 1 over 6. It's 1/6, right? And we can figure it out as a decimal if we like, but we can just leave it as 1/6 as well. So that means that if I'm going to put a negative 2 in for x, that's the same as saying 1 over 6 to the power of 6 squared, right? Which in reality, that's the same as saying 1 over 36, because 6 squared is 36. So any of those negative exponents, you're going to end up putting them, you know, in a fraction form to make them a positive exponent. Okay?
Mm-hmm.
Once you've done that, it's a matter of let's just plot all our points. Okay? So if I look at this and I say, hey, I want this to be, you know, negative 2 and 136. Well, negative 2 is going to bring me in here, and I'm going to be really, really close to the x-axis, right? It's going to be super close. Not on it, but super close to it. If I go to negative 1 and 1/6, same thing. I'm getting a little bit further away from the x-axis. And I apologize because these graphs are kind of, the grids are really, really tiny on them. And then I go to 0 and 1. So I'm going to place that point there. And I'm going to go 1 and 6. 1, 2, 3, 4, 5, 6. Place a dot. And you start to see what's happening is you're starting to get this, oh, I've got an increasing graph, which makes sense because 6 is our base. It's larger than 1. So it should be an increasing graph. And then if I look at 2, I know I'm going to be way up here at 36. I don't have the space on my graph to do that. So if I start to connect all my dots together, I've got a graph that's looking something like that. Okay?
Mm-hmm.
Does that make sense?
Yep.
Yep.
Okay. So now, a few things to take note as we're doing this. It says, hey, what's the domain? So if I think of domain here, what would my domain be? So think of domain as your x values, right? Do you have any limitations on your x values? So really, I'm going in this direction forever and ever and ever. And I'm really, if this graph could go on forever and ever and ever, which would mean it would go on to the right forever and ever. So my domain is simply negative infinity to positive infinity, okay? There's no limitations on that, on my x's at all. My range, now let's think range. That's our y values, right? So think about it in this direction. Where's my lowest y value? So if I think about this it's not crossing this x-axis here. So my y here is at 0. So my lowest is at 0, and I am going all the way up to positive infinity. So that we're going to stay true to what we've got, right? So that's domain and range. Then I have my x-intercept. Well, x-intercept would mean that I would be crossing my x-axis. And in this case, I am not crossing my x-axis, so there is none. So in this case, your x-intercept is none. And your y-intercept, well, my y-intercept, it is right here, right? That was that point 0 and 1. So my y-intercept is 0, 1. Oh, I ran off my paper. Sorry, guys. Okay, so that takes care of x and y intercept. So whether the graph represents an increasing or decreasing function. So are we increasing or decreasing here?
Increasing.
You betcha. So this is an increasing. And so that was that. And then the equation of the horizontal asymptote. Okay, so horizontal asymptote, that's what we were talking about earlier. So this graph is not going to cross this x-axis, which means that that is My horizontal asymptote, so I'm just going to put HA for short, is the equivalent of y is equal to 0. And for the most part, any of our basic functions right now that we're working with, that we're not putting any transformations to, your horizontal asymptote will always be y is equal to 0 because we haven't shifted it up or down at all, right? So that will stay true to that. How does that feel?
Makes sense.
That makes sense? Okay, let's try the second one then. So let's look at this next one. Hey, predictions. Is this going to be an increasing or decreasing function?
That's going to decrease because it's a fraction.
You betcha. So this is a decreasing. So right off the bat, we know just by looking at our graph, we're dealing with a decreasing function. Okay, so same thing. Let's do my x and y's to this. And again, negatives, put 0, and put a couple positives. So the fun thing here, what we get to work with is you've got 1/5 to the power of x, right? That's what we're working with. So now when we go to figure this out, if I put 2 in here for my x, I'm going to end up, because I have a fraction in here and I put a positive exponent in, I'm going to end up with a fraction for an answer. So in this case, 5 squared is 25. So this is really going to be 1/25, right? So by putting 2 in for x, I get 1/25. If I put 1 in for x, I'm going to just simply get 1/5. And then if I put 0 in for x, well, same thing. Anything to the power of 0 is going to give me a 1. No matter if I'm dealing with a fraction, if I'm dealing with a whole number, whatever it is, I'm still going to get that 0, 1. Now, here's the fun thing. So now if I go and put a negative exponent into this one, so that's really saying if I've got 1/5 to the power of -1, I need to make that a positive exponent again. Well, that means I'm going to have to take this fraction and take the reciprocal of it, which would mean that I would have 5 to the power of 1, all to the power of 1, right? So in this case then, if I put a negative in, I take the reciprocal of that fraction, I've got 5 to the power of 1. This should give me an answer of 5. So same thing, if I put a -2 in for x, I take the reciprocal, I'm going to have 5 to the power of 2. That's going to give me a 25. Which kind of makes sense. It kind of is the opposite of what we were doing over here, where we put negative values in. That's where we ended up getting our fractions when we were dealing with an increasing. Now when we're dealing with a decreasing, our fractions end up at our positive values of our function or our exponents. So if I do the same thing, I'm going to take those values. So I've got -2 and 25. Well, 25 is going to go off my chart, so I'm just going to label it as 25 up there. And I'm going to go -1 and 5. 1, 2, 3, 4, 5. I'll put that point in there. And 0 and 1. And then I'm going to go 1 and 1/5. So close to the x-axis, not quite there. And 2 and 1/25 is getting closer to the x-axis. So again, you start to see this lovely exponential curve start to happen. And it's going to look something like that. So you're right. We've graphed it right. We know it's decreasing. We've got the looks of it. We see that. So now think about, what is your domain?
When isn't that just -infinity to +infinity again?
You betcha. So this one, again, still doesn't change. I have no restrictions on my domain. It goes in both directions, right? And then my range? So think again, you're dealing with low to high. So you're still dealing with your lowest y value being 0 to infinity, right? X-intercept, don't cross anywhere, so you have no x-intercept, and your y-intercept,
1.
yeah, is that 0, 1 again. We know it's decreasing, and our horizontal asymptote is still that y equals 0, right? Because it's approaching that x-axis, getting really close, but it doesn't actually cross it. How does that feel?
Makes sense.
Good.
Okay, that's good. All right. Let's go to the next piece. So this time what we've got going on is you've got a lovely graph happening, okay? So in this case, we want to know, based on the graph, can we actually write what the exponential function is? Can we figure out, so if we want it written in this format, we need to figure out what is C, what is our base? What's that gonna be? So how do we figure that out? First off, think about this. Is this an increasing or decreasing graph that we've got going on?
The first one's decreasing. So
Okay,
A is
so this
decreasing.
Yeah, this is decreasing. What does that tell us about what C is going to be?
It's going to be a fraction.
It's going to be a
Or-
fraction. Yeah, you're right.
Yeah.
Or a decimal or something, right?
Yeah.
It's going to be less than 1. Okay, so now we got to figure out what value goes in there. So if it is a fraction, think about the points that you've got going on in here, right? So if I treated this as I've got a -2 and 16, I've got a -1 and 4, I've got a 0 and 1, and then it looks like I've got a value at 1, that's going to be something really, really, like it's getting smaller, isn't it? And then at 2, it's even smaller yet. So what we need to figure out is, if we knew what x was, if wherever x is 1, we'd be able to figure out exactly what that base was, right? Like if we think about it back in our originals back here, have a look at these ones. So look at, when x was 1, we found our base to be 6. So in an increasing one, where if we can find out what our value is, our y value is at x equals 1, then we figure out what that base is. Over here, when we figured out what 1 was, we figured out that that was our base of 1/5, right? So think about it then as, hey, what happens at -1? Because you start to see that piece, especially in our decreasing. So at -1, we found out that we had a 4 in there, right? So that's basically saying that, well, C to the power of -1 is actually the equivalent of saying that that is equal to 4. Well, we know this needs to be a fraction because you said decreasing. So in this case, then this magic number of 4, that must be what makes our actual function. That's what makes our base in it. So let's think about this. If I put a 1/4 to the power of -1, so if I went 1/4 to the power of -1, that's the same as saying 4 to the power of 1, which if I'm looking at this, that equals the 4 that I need it to be. So this must be my function. So think about the second one. So is the second graph that we've got increasing or decreasing?
Increasing.
Increasing.
Yeah, so this is increasing. So if we're dealing with increasing function, let's think again, find where x is equal to 1. Is where x equals 1? If I put a 1 in here, I'm going to get what my actual base is. So my function in this case will be, because it's increasing, I know it's going to be a whole number in here. It's got to be larger than 1, so it won't be a fraction. So in this case, it's going to be 5 to the power of x. And that will be what my function is going to be. How does that feel?
All right.
It's okay.
That one's a little wonky. So one thing to take note, if you're dealing with the decreasing, you know you're going to get a fraction out of it. So basically either go to the one that showed up as a -1 and 4, right? So that 4, we took the reciprocal of it to make it a 1/4 because it was decreasing. Mm-hmm. Over here, if I went to the increasing one, I went to where I had x equals 1, and that gave me what my actual base will be. Okay. Mm-hmm. Okay, that's kind of all I'm going to show you today, which then leads us into, I think you'll have your, you probably can go ahead and work on your very first assignment in your notes package when you print it out. Go to assignment number 1 and kind of fiddle through that one and play around with that one. And I think there's lots of find your domain and range, find your x and y intercepts, and all of those pieces as you move through it. Okay.
All right.
Do you guys have any other questions?
No.
No?
Oh, it makes sense.
So
are we gonna have like what do you call it? The answers for it?
They should be in your notes package, absolutely.
Okay.
Will we be doing
have
Oh, sorry.
No, go ahead.
I was just wondering if we'd be doing something like equivalent to a test for this.
I might throw an exit slip. I might get you to do a question for me just to see if you're, how you're making out. But once you work through your assignment questions, as you're working through them, if you have troubles, just text me on Remind. Take a picture of what you're working on if you get stuck on something and let me know, right? I'll have a pretty good idea. As long as we're communicating back and forth and kind of staying in touch, I'll have a pretty good idea where you're at with it, right? Mm-hmm. The only time that I would consider throwing a test at you or doing something like that is if you wanted to improve your mark.
Okay.
Okay. Otherwise, this is more or less just for you to fill in some of those gaps and, worry about things for next year, what that looks like, right? Because I don't want you to have some holes in your learning moving forward, right? So.
Mm-hmm.
Makes perfect sense.
Okay, cool. Okay, on that note then, what we'll do then on Thursday, we'll actually get into the transformations of exponential functions. So we'll actually get into the A and the B and the H and the K and look at shifting these graphs up and down and left and right and all that fun and wonderful stuff to them. So today and tomorrow, just focus on doing that first assignment and kind of playing around with that and kind of getting your brain around the idea of doing exponential functions and graphing them and kind of answering questions that pertain to them. Okay? All right.
Okay.
That's it. So if you have no other questions, then you guys are free to go and tour on your day, and we'll see you back on Thursday at 1.
Thank you. Have a good day.
You too. Okay, take care, guys.
Thanks.